All right, this is the second video for Geometry A, Unit 8, Lesson 7, I believe. Actually, Lesson 6. Lesson 6. There was not enough time because I took so much time doing the proof of the mid-segment theorem to do the two application types of problems that they presented. One was this. You were given a triangle, two triangles that share a side, or share an angle here. Let's draw the scenario we're talking about. Okay, and let's draw it like this here. Here we go. And in this case, the sides aren't proportional. There's, or I should say, the sides aren't parallel. Oops. But rather, there's this flip-flopping going on. Something like this. Okay, and we're given this information. We're given ABC, triangle ABC is similar to triangle DBE. Triangle DBE. This is one of those cases where almost the picture proves to be more confusing than just looking at the letters. But you're given some of the dimensions, like AE is 9, EB is 7, BD or DB is 8, and let's say that ED is 4. You're asked to find X and Y. Okay. Well, if we take the statements for what they say, ABC is similar to DBE, then corresponding sides are proportional. That is, AB to DB is the same as BC. Let's offset this a little bit because we're going to run into something. BC is to BE. And should also come out the same as AC to DE. So AB to DB, so first two. BC, second two to BE. And then AC, first and last, to DE, first and last, are all the same. Let's fill in the values that we have here. AB is to DB. AB is 9 plus 7, because AB is this one right here, 9 and 7 added together. DB is 8. 9 plus 7 is 16. 16 to 8 is 2. So the ratio is 2. And these should all come out to be 2. BC is right here, y plus 8, to BE, 7, BC to BE, yep. And AC is to DE. AC, X, is to DE, 4. Okay? So what we have is all of these should equal 2. So I've got a pair of equations I can solve for the unknowns. Y plus 8 over 7 is 2, and X over 4 is 2. Let's go ahead and solve that. Okay? Let's solve Y plus 8 over 7 equals 2. Let's start by getting rid of the divide 7. The opposite of divide 7 is times 7. Divide 7 and times 7 undo each other, so y plus 8 is 14. Subtract 8, and y is 14 minus 8 is 6. So y equals 6. Okay? And then x, same idea. Let's go red here. So x over 4 equals 2. Multiply both sides by 4. And x equals 8. So x equals 8. And if you look at these, what's going on here is the red triangle is similar to the blue to the large blue triangle by first reflection. So if we take the angle bisector and flip this over, then this will end up on the opposite side of that line. This will end up on the opposite side of that line. And these will be parallel. So there's a reflection going on. That's the transformation that makes them match up. Okay, reflection and dilation. Right. So, like I said, the key to this is taking the statement itself and writing proportionality statements from the letters of the triangle and then filling in the blanks and solving any equations that come up. All right, so that's one. And then the other problem type was when we have indirect measurement. Let me give you an example. Okay, I want to measure the height of a flagpole. So let's say we've got a flagpole here, and flagpoles are notoriously hard to measure because it's difficult to climb a flagpole. There are some that can do it. I used to do it when I was a kid, but I don't do it anymore. And here's the scenario. We're going to go and we're going to stand 40 feet away from the base of the flagpole. 40 feet. And we're going to place a mirror on the ground between us and the flagpole. Between us and the flagpole. And the mirror is going to be positioned so that I can see the mirror I can see the top of the flagpole in the mirror. Okay? So I can see the tip top of the flagpole in the mirror. Now, if you understand physics, the idea is that the angle of incidence equals the angle of reflection. In other words, things bounce off at the same angle they come in. Okay, so here we go. We're looking at the flagpole in the mirror on the ground. Okay, in the mirror on the ground. And we measure the distance between us and the flagpole. And that distance is 8 feet. And my height is, my eyes are going to be, I'm going to say 5 feet above the ground. Okay, so what is the height of the flagpole? Now, the whole length between me and the flagpole is 40 feet. So this is 40 minus 8, or 32 feet. And the angle of reflection equals the angle of reflection. And the flagpole is standing straight up, and I'm hoping that I'm standing straight up. Okay. And so by angle, these are similar triangles. And so we can write and solve a proportion. X is to 5 as 32 is to 8. And then cross multiply and divide. The solution to a proportion is the cross product and division. X times 8, 8x. equals 5 times 32. I'm going to leave that for now. Divide by 8. Okay, and x equals 32 divided by 8 is 4. 4 times 5 is 20. So the flagpole is 20 feet high. And I measured that without having to climb the flagpole. I just measured the distance between me and the flagpole and the mirror in the flagpole and my height above the ground. So it's an example of indirect measurement in similar triangles.